All right, so in section 5.1, we left off with the scientific notation stuff. Okay, so a lot of teachers get really like hung up on moving things to the left or moving things to the right with scientific notation. I just want you to think of if it's a big number or a really small number. So when we use scientific notation, we use it for like huge things, like the weight of a planet, or the weight of or little tiny things, like the weight of an atom. Okay, so kind of the extremes. So as you're doing that, I want you to think, is this like a big number or a small number as you're doing the problems? Okay, it's always when it's in the form a times 10 to the n, and a is a number that's between 1 and 10, but it can't be 10. So when you see scientific notation, it can be like 1 times 10 to the 5th, or 9.999 times 10 to the negative 10. Right? But you're never going to have like two numbers in front of a decimal point. That's what we're saying there. And then n is an integer. So you're not going to have like 10 to the 1/2. Like, we're not going to do that. Okay, so here's some basics. So it says big numbers have positive exponents. Little tiny numbers, like the weight of an atom, have negative exponents. Okay, so that's the important concept. So don't think right or left. Just think make the number bigger, make the number smaller. So in the first one, you have 3 times 10 to the 6th. So you start out with your 3, and you move the decimal place over to make it bigger because you have a positive exponent. So you go 1, 2, 3, 4, 5, 6. So you have 0, 0, 0, 0, 0, 0. So that's how you end up getting this number here. Okay, so same idea with 5.6 times 10 to the 4th. Since you have a positive exponent, it's going to get even bigger, right? So you're going to start with your 5.6. Your decimal place is here. You're going to go over 1, 2, 3, 4. You do those little swoop things. So you get 56,000. All right, the next one is 1.53 times 10 to the negative 4th. So start with your 1.53, but you move your decimal place over, and now you want to make it a small number, right? You have a negative 4 as your exponent, so it's going to get smaller. So you move that decimal place over 1, 2, 3, 4, like that. So it's 0.000153. So that's how we got this number. And then the next one is 9 times 10 to the negative 3. So same idea. You start out with your 9, but you want it to get smaller because you have a negative exponent. So you're going to move it from here, 1, 2, 3, and put your new decimal point. So you have 0.009. I hear Mr. Crowley is very anti-swoops. It's okay, you can draw the swoops in my class. I think they're helpful. I still draw the swoops. So do whatever you need to do. All right, so it says, remember, big numbers have positive exponents and small numbers have negative exponents. So you should know how to do all of these different things. Do you guys remember how to do these? So we're going to change to scientific notation. So I'm going to take from where my decimal place is now, and I'm going to move it until I get my number between 1 and 10. So I'm going to go 1, 2, 3, 4, 5, 6. So I get 1.3. And it was a big number, so it's 10 to the positive 6. Same thing on the next one. So I have 250, so my decimal point's on the right. I need to move it so that my number's between 1 and 10. So I move 1, 2. So I get 2.5 times 10 to the 2. Okay, this next number is a little bitty number. It's way smaller than 1, right? So I'm going to move 1, 2, 3, 4, 5, 6, 7. So 5.6 times 10 to the negative 7. Did you guys get that? All right, and the next one's a small number. Again, smaller than 1. So I'm going to move it over just one place to get 3. 3 is between 1 and 10. So it's 3 times 10 to be negative 1. Remember all of these? All right, you guys try the next 4. See if we get the same thing. All right, hopefully this is all review for you guys. So 25,000, if you move your decimal place over 1, 2, 3, 4, you get 2.5. So you have 2.5 times 10 to the 4th. This next one, I think you should get 3.89 times 10 to the, I think it's 10, right? Move it over 10 times to get it to 3.89. Is it 9? It's 8. Uh-oh. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think it's 10. So So you got to move it so that your number's between 1 and 10. All right, and then the next one, I think it's 4.5 times 10 to the, so how many did you guys get this time? Negative 10? Okay. And then this next one is 6.89 times 10 to the, you just move it over one time, right? So 10 to the negative 1. Okay, so just think, do I have a big number? I use a positive exponent. If I have a little number, negative exponent. Okay, now the whole reason we have scientific notation is so we can multiply and divide large or very, very small numbers quickly, okay? So this is why this is in this section, because we've been dealing with exponents. So in this first one, I have 3 times 10 to the 2, and then times 2 times 10 to the 4th. So multiplication is commutative. You can move things around. So I'm going to have 3 times 2, and then I'm going to do the 10 to the 2 times 10 to the 4th. Now these are not x's, right? These are just times signs. So 3 times 2, I think I said 4 before. 3 times 2 is 6. And then you have your 10 to the 2nd and 10 to the 4th. Just like x squared times x to the 4th would be x to the 6th. Same idea here. So you get times 10 to the 6th. And that's your answer. So 6 times 10 to the 6th. Okay, so the second one's just like that. You can move things around if you need to, but you don't have to. Like, you can see the 1.4 and the 2 will combine. You'll get 2.8. And then you have 10 to the negative 2 times 10 to the 4. So that's going to be 10 to the 2. You add your powers. Okay, so most of them are pretty straightforward. But things like the next one, it can get a little bit confusing. Because when you multiply this, you have 7.6 times 2, which is 15.2. And then you get 10 to the 20th, but there's a problem because this isn't in scientific notation, right? And it's not in scientific notation because that number isn't between 1 and 10. So you have to move it around, okay? So what we need to do is, there's 2 different ways you can do this. So one is like, for all of you analytical people that just want to see like the math behind it, like you're going to want to see this. So the 15.2, you rewrite using scientific notation. So you would rewrite as 1.52 times 10 to the 1st, right? You just move it over one time. But you still have your times 10 to the 20th. So do you guys see how those now combine to become 1.52 times 10 to the 21? Does that make sense? Okay, now for all of you visual people, there's another way. Okay, this is how I think of it. Okay, I like to think of the swoops. So here's what I do. I think of my 1.52. And I think, oh, if I'm going to multiply by 10 to the 20th, I'm going to have my 1.52. And I'm going to move this over, right, 20 times. Does that make sense? Okay, I'm not literally going to move it over 20 times. I'm thinking in my head, I'm moving it over 20 times. All right, and then I'm going to move it back. So as I move it back, right, I have my 20 times, but then I have to go one more to get it between 1 and 10. Do you guys see that? So that's why my final number is 21. You see, so it's like you put it back in standard and then put it back in scientific. And you could do that like with these problems. Like sometimes on homework, I see people turn it in and they've changed this to 300 times 20,000. And then they multiply it out and then they change it to scientific. Well, that's great. I'm glad you guys could do that. But like, that's defeating the purpose of having scientific notation, right? Like, why would we do that? Like, we're trying to avoid writing out lots and lots of zeros. So if I have 3 times 10 to the 100, like, don't write all of those zeros. That's crazy. Okay, does this make sense? Edward, did you have a question? You got it figured out. Okay. Next thing. Oh, I did that page twice. Okay, so these last ones. So I have 9 times 10 to the 3 over 3 times 10 to the 2. So now we have division. So same idea. So it's really like you're taking the 9 and the 3 and you're dividing them out. So you get 3. And then you're taking the 10 cubed and then 10 squared and you're dividing it out. So you get 10 to the 1st, right? Your subtraction rule. Just like x cubed over x squared. All right. Basil, stop. All right, so then this one, same thing. So 6 divided by 2, so I get 3. And then times 10 to the 15 over 10 to the 10, 10 to the 5. But number 6 is one that is kind of strange, because now when you do the 8 divided by 16, right, you get 1/2, which is 0.5. And then here's, this is also tricky too, right? You have 10 to the 8th divided by 10 to the negative 4. What did we do when we had x to the 8th divided by x to the negative 4? You subtract. So you do 8 minus a negative 4. which is 8 plus 4, so you should get 12. So this is times 10 to the 12. What we also did is, remember, we moved this to the top and made it positive. You could also do that. So move it to the top and make it x to the 4th. That's why you're adding. Okay, but we have a problem because now this is not in scientific notation because we have that 0.5 issue, right? It needs to be like 5. So like I said, you can write this as 5 times 10 to the negative 1, right, this part here, and then still have your 10 to the 12. So you can easily see it's 5 times 10 to the 11. Or you can do the thing that I was talking about where you think of that decimal place moving, right, so the number gets bigger, right, 12 times. But to get it so that it's in scientific notation, you have to move it back, right, to right here, 11 times. So it's 5 times 10 to the 11. Okay, does that all make sense? Okay, so let's do the next section.